For example 2, you're going to see how commutative property of addition is being used, or associative property of addition is also being used. You see here, we have in parentheses two fractions that do not have a common denominator, but we have one outside of the fraction that has a common denominator. What we can do is we can regroup it, right, and work with those two first, and then later find a common denominator for 4 and 9. So you see that's being done here. Okay, they've regrouped it right there, okay, so that they can figure that one out, and then we're going to find a common denominator. Or as you can see, this makes 4 out of 4, which is 1. Okay, so we have 5 9ths plus 1 is 1 and 5 9ths. It's looking like this is going to be a two-part video because it's getting a little long, but it's a tough lesson. It's a lesson that really needs to be explained well. Anyways, let's move on. Let's look at the associative property for this. I see that I have 2/5 and I have 3/5 here. Let's group those two together into two. Oh, I keep using that color. I have 2/5. Okay, so I've grouped those, and I know that this is going to give me 5 out of 5. Okay, plus 4 to 5, 4 to 7. Now don't forget that this is 1, so that's going to equal 1 right there, and 4, 7. And we can use associative property here too. We have -3/10 and we have 23/10. Oh, an improper fraction right there. That's not common. Let's group them. You should have something that looks like this. Okay, and when we do the math here, negative plus 20, it's going to actually be 20 over 10 plus 5/8. And when I divide 20 divided by 10, I'm going to get 2, right? I'm going to get 2. So I get my 2 here plus 5/8 equal 2 and 5/8. There you have it. For example 3, they're talking about using a number line so that you can see how it works together when you're subtracting negative fractions. Okay, and we have this on the bottom of page 293. Okay, again, let's find a common denominator for this one, for this one, and for this one. We already know that this one's going to be 12, and we know this one's 8, and this one's going to be 10. Right? 10, like products, if you were to count, or make multiples, like multiples. Okay, I hope you were able to figure that out. I didn't do anything to the 8 here, so I don't do anything to the 5, but I did double the 4, so I must double the 2, I mean the 1 to a 2, so I have that, and my answer will be 3/8. On the next one, I had to multiply this by 3, so I must do the same to the 3, and it becomes 9. I had to multiply this by 4 to make it 12, so I must multiply this by 4, and I get 4, and 9 minus 4 is 5/12. Okay. And over here, minus minus is adding. Don't forget, you're taking away negatives. I had to multiply this 2 by 5, so I must do the same to the 1, and I get 5. Minus, I had to double the 5 to make it 10, so I must double the 4, it's going to be 4. But minus means I'm taking away potential negatives, so it's going to give me 9. It's actually like adding, so it's 9/10. And there you have it. For example 4, you're given a word problem, okay, with the blood type frequencies table here on the right. Take a look at it, please. Take a look at it. This video is already long enough. Add or subtract unlike fractions to solve real-world problems, okay? Take a look at this real-world problem and look at the therefore statement. Hopefully it makes sense. If it doesn't, ask me in class. As always, here is your guided practice. Leave this for class so we can do it as a warm-up together. But please complete the independent practice on your own. Remember, you can always reference the examples. For example, these questions, you can reference examples 1 to 3. And down here, you can reference examples 4 and so on. Alright? Whatever you don't understand, make sure you ask me in class. See you then.